Place a drop of water on a smooth surface and watch it closely. It doesn't spread out completely. It pulls itself together into a tiny bead. No bonds are breaking, no new molecules are forming. So what's holding those water molecules together? The answer is intermolecular forces, the quiet, invisible attractions between molecules. Let's go a little deeper. Atoms bond to form molecules, but molecules also attract each other. These attractions are weaker than chemical bonds, yet they control how substances behave in everyday life, whether something is solid, liquid, or gas. Here's something even more interesting. Water molecules stick together because of hydrogen bonding. Oxygen pulls electrons strongly, creating slightly positive and slightly negative regions. These tiny charges attract nearby molecules, locking them together just enough to form liquid water. That's why water has a surprisingly high boiling point. That's why ice floats. And that's why life can exist as we know it. But wait, hydrogen bonding isn't the only force at work. Some molecules attract each other through dipole-dipole forces. These happen when one side of a molecule is slightly positive and the other slightly negative, like tiny magnets lining up. These forces explain why certain liquids mix well, why some smells linger in the air, and why polar substances dissolve in polar solvents. Now here's the most surprising twist. Even molecules with no charge at all still attract each other. These attractions are called London dispersion forces. They come from brief, random movements of electrons that create temporary charges, appearing and disappearing in an instant. They're weak, but everywhere. They explain why gases can liquefy, why wax is solid, and why larger molecules tend to have higher boiling points. Let's connect this to real life. Why does alcohol evaporate faster than water? Why does oil not mix with water? Why do proteins fold into precise shapes inside your body? All of it comes down to intermolecular forces. Before we wrap up, zoom out for a moment. Chemical bonds build molecules. Intermolecular forces decide how those molecules behave together. And that leads to the next question. If these forces control physical behavior, how do substances change when energy is added or removed? Why do solids melt, liquids boil, and gases expand? That's exactly where we go next, into the behavior of matter itself.